Okay, so the next set of problems have to do with scientific notation. For the first two, we're going to turn these numbers into scientific notation. For the second two, we're going to take numbers that are in scientific notation and turn them into normally written numbers. Alright, so first things first, I don't want to spend too much time on this. The rules are, for scientific notation, you have a number between 1 and 10, and then it's multiplied by 10 to some exponent to give you the correct magnitude. Here I have the millions, so I know at some point I'm going to have times 10 to the 6th power, because 10 to the 6th power, if you type it in your calculator, equals 1 million. So here, I am going to take this here. How do I know it's 6? I'm going to pretend I have a decimal there. 1, 2, 3, 4, 5, 6. I need to move my decimal 6 places. And I want this 4 point whatever, I need it to be 4 point something. So this equals 4.602 times 10 to the 6th. And again, I move my decimal 1, 2, 3, 4, 5, 6 times. And then you might be wondering, how do I know it's not negative 6? How do I know it's positive 6? Easiest way to remember this is if you're dealing with a very large number, a number larger than 1, it's going to be positive 6. If you're dealing with a very small number, this is less than 1, then I'm going to use some negative exponent here, okay? So this second one has the same rules. I need to move my decimal from here to right here. So I want this to be 4.03 times 10 to the something. And now I'm dealing with a very small number, so I know it's going to be negative something. And I move my decimal 1, 2, 3, 4, 5, 6. So this is to the negative 6th. Simple as that. Make sure you have a number between 1 and 10 in the front here. So it's, in this case, it was 4.03. I don't want this to be 40.3. That is not following the rules for scientific notation. It has to be between 1 and 10. Keep all your sig figs on here. I only have 3 significant figures. I keep all of them. Here I have 4. I'm going to keep all those. And then however many times I move my decimal is what this exponent is. If I have a large number, it's positive. If I have a small number, it's going to be negative. There we go. All right, let's get to the next two. Okay, now we have C and D. All we're doing is turning what is currently scientific notation into, again, whatever the normal notation for writing numbers is. And we want to use the same guiding principles here. That's a negative 8. I know I have to move the decimal 8 times. It's negative, so I know this number must be very, very small. Less than 1. Which means I'm going to move my decimal in the direction that makes this number very small. If I move it to the left, I'm going to have 0.0000 something. If I move it to the right, I'm going to have 9, billion or 955 million or something like that, or whatever it is. And that's a huge number. So I'm going to use my common sense here, which is our best friend in any science class, and say, oh, this is negative, this must be a very small number, let's move it 8 times. 1, 2, 3, 4, 5, 6, 7, 8. Here's my decimal. Every little loop I have, I'm going to put a 0 in there. 1, 2, 3, 5, 6, 7 zeros. There we go. So our answer is, I'm going to write it down below here. So I have 0.1, 2, 3, 4, 5, 6, 7 zeros. 1, 2, 3, 5, 6, 7 zeros, and then 955. There we go. That's the answer for letter C. Let's do this with the next one. This is a positive 4. I know this number is going to be large. So I'm going to move my decimal in a direction that makes it large. 1, 2, 3, 4. In this case, I only need to add one more 0 to it. So here, we're going to get 24080. There we go. I think that'll do it for scientific notation. Let's move on.